Okay guys, welcome to week 4. I already did another video for week 4 on Slack space or file Slack. This is by request. A student actually emailed me or texted me and said, hey, can you give us a little bit of insight into what's wanted for the lab 4.2 FTK Imager and autopsy? So sure, absolutely. We'll keep it short. I don't want to give away too much. I want you to do your homework and do the lab without giving you all of the answers, but to kind of walk you through it, first thing you'd want to do is read the assignment. So download the 3.2 lab.zip, which you should already have done for last week's assignment. It's a WinXP.eo1 file. Some of you struggled with the concept of importing that file into FTK Imager. You have to unzip it first, and that's a common rookie mistake. So don't feel bad if that was you. I'm sure I even did that the first time. You have to unzip it, and then you have the EO1 file outside of the zip file, and then you can upload it into FTK Imager or Autopsy or your other utility of choice. It says we need to document the partitions found in the image, the master boot record, unallocated space within the partition where you find the operating system. And that's kind of an odd request. As I'm looking at that, I'm not really 100% sure what they mean by unallocated space in the partition containing the operating system, other than maybe there is remnants of another operating system, or there's a hidden partition with another operating system on it. I'm not sure what that means, so we'll have to look around. It could mean any of those things, or it could just be a poorly worded question. Unused space on the drive. So where are there no partitions, and are there any clusters available after the disk has been partitioned and the volume has been created? Screenshot and create a slideshow of your examination, and then here's the rubric. Always look at the rubric. 20 points to create a slideshow, and I really think to get the full 20 points, there needs to be at least 8 slides or at least 8 screenshots. So if you only had, 6 slides, but each one had 2 screenshots, so you had 12 total screenshots, I would count that as a 20 point. Assuming that the screenshots you took were relevant and you're not just randomly screenshotting stuff. And then explain the process associated with that screenshot, why you took a screenshot of that particular part of FTK and what you're trying to point out. And then you want to create just a couple of sentences describing that screenshot. Like, I took this screenshot because it's a picture of the master boot record, and we know it's the master boot record because the master boot record is found at this file offset, and then here's a reference to Brian Carrier, or to your textbook or whatever, and some kind of APA formatting where you create a little parentheses for your source, and then at the end of your slideshow you've got a nice list of several resources where you're getting this information. You're not just making it up. Please don't use me as a resource. I'm not a published expert in this field. I'm an expert in the field, but I'm not a published expert, so I don't really know that these YouTube videos or these class videos count as me being a published expert. I'm basically your guide through this process, and I want you to go out and find out what people who've done more research than I've done. I want you to find out what they're saying about it. All right, number 10, the next point down, explain the process. Yep, just covered that. Proper grammar and spelling. I'm not a grammar Nazi. I'm not a spelling Nazi, but if you have blaring mistakes, then I'll probably point those out. They have to be pretty obvious, though, because I'm not an English teacher. I'm pretty good at writing reports. I know what to look for. I'm not going to nitpick you too much, but if it's really bad, I'm going to point it out, because what I don't want you to do is leave college and write a report for your boss or for your client and have it be crap, right? So I'm gonna look for things that would stand out and make you look stupid, because I don't want you to look stupid out in the real world. And then provide that in-text citation and a research page like we discussed. All right, so there's our assignment. Let's go ahead and kind of do it. So I've opened up FTK Imager here. Up here in the upper right corner is our evidence tree. We need to add evidence. Okay, so what we're going to do is we're going to click on the little green plus in the upper right corner, and it pulls up the select source. Are we going to pull up a physical drive? No. Are we going to pull up a logical drive? No. Are we going to pull up an image file? Yes, because that's what we just did. Now remember, we already unzipped it. We're going to browse for the path. I know I stored mine right here under my UAT CFR 101 week 4 lab. And then within the week 4 lab, there's a file folder that says week 3.2 lab because it's the same. Open that up. I've already unzipped it. It's just a WinXP.eo1, so that's what I want. If I just click that and hit open, it will in fact open it in FTK Imager. All I have to do is click finish. And here we go. Here's our image or forensic copy of this Windows XP drive. Now, it's a partition. And the first thing I notice when I look at this is that the name of the image is WinXP.eo1, and right under that there's one partition, and then it looks like there, and within that partition there's a volume that has no name, but it's an NTFS file system, and there's a root directory, and then FTK Imager creates two other folders. They're virtual folders, they're placeholders, they're not actually folders on this partition or this volume. It just puts them there as a way to organize unorganized data, right? So, for example, unallocated space, everything left over, everything within that partition that's not being used. And then orphan files are deleted files or directories that whose parent directories have also been deleted, okay? But the orphan files themselves, or the orphan directories, they're still complete enough that the file system recognizes them, but they don't have a parent folder or directory anymore. So they're orphaned. So FTK Imager does a nice job of kind of going out and categorizing some things for us that we would never do we'd never find just by mounting the drive or mounting the image and looking at it in Windows Explorer. All right, so and then there's some unpartitioned space, and this is leftover space on this disk. I'm wondering if this wasn't created using like you know what I'm trying to say? Help me out here, people. If it wasn't created using a VM. So it's probably a virtual machine. That's a common way for, academics to create a forensic copy, is to use a virtual disk or a VM and then create the image. So interestingly enough, they included some unpartitioned space. Okay, so and if we look at that, there's some information that shows up down here. All right, so let's take a look. So the first thing I'm going to look at here is the image, and look at this. It gives me some interesting stuff. First thing I want to document is this kind of stuff. Okay, hash verification. So that's the hash verification of the whole image. Bytes per sector, 512. Really useful for our determining file slack and things like that. How many sectors there are on the disk or the on the drive. Yep. Image type, it's an EO1. Nobody put in the case number, evidence number, blah, blah, blah. We know it's a XP operating system. Acquired back in 2008, back when XP was still being used. Okay, so why not take a screenshot of this just so that we can document that we know where this image came from? So I click on my snipping tool, I click new, I go up here and I say, here is a snip, right? I can save it or copy. I can just copy it and paste it right into my report. So, right, if I had a report open, I could do that. Just copy and then paste it into the report. All right. So, and then I would type something like, this is the first screenshot. It's documents the information, metadata about the image file, including its hash verification, how many bytes per sector, when it was created. Good enough, okay? Do I want to save that? No. All right, so then I would go down and I would look at the partition itself. And it tells us that the starting sector is 63. Usually the first 63 sectors on an NTFS disk, or in fact, it's common for most file systems and operating systems, is to put the starting sector of the partition out on 63, because the first 63, 0 through 62, right? Sector 0 through 62. So the first 63 sectors are actually reserved for file system and operating system and boot up and things like that. So sorry about that. I just coughed right on you. Okay, so that's useful. Okay, and so I would probably take a screenshot of that. Get my snipping tool again. New snip. I'm gonna just kind of drag my little arrow around there and document. This is some metadata about partition 1, including the number of the starting sector and the total number of sectors. Now that'll be useful, right? This total number of sectors, because we want to see if there's any hidden partitions by looking at the total number of partitions on the disk or the total number of sectors on the disk and see if that adds up. Okay, so that would be a really good forensically sound operation to perform. All right, and then we get down into the volume, right? So the actual formatted part of the partition, and it looks like, okay, we've got some property information over here. The cluster size is 2048 bytes, so that's how many sectors per cluster? Well, that's 4 sectors per cluster. Why do I know that? Because I know that there's 512 bytes per sector, right? We found that out. Where do we find that out? Up on the partition information. Nope, I lied, totally lied. Up on the image information, the drive geometry, it told us that it was 512 bytes per sector. All right, so we're still back here at the volume level. Incidentally, and if you're paying attention, you notice I'm using words like partition and volume, which are often used interchangeably, but I'm using them specifically, right? A partition is a piece of a disk that has been sectioned off and reserved for some kind of use. A volume is a section of typically a partition, which has been formatted with a specific operating system, or excuse me, a specific file system, and is readable by an operating system. So that's where we use those terms interchangeably, but technically they're different. Okay, so we know our cluster size is 2048. It has 4 sectors per cluster. There are this many clusters, 785,000 clusters. There are some free clusters on the disk. So unallocated clusters is presumably what that means. We would want to investigate that and confirm that. No dirty flag. Don't have to worry about that. When it was formatted, the operating system gave this volume a serial number. That's different than the serial number of the disk. It's the volume serial number. Now, the file system version was WinXP, and it uses UTC timestamps. All right, so looking now that we're on the volume, the first sector of the volume, the first 512 bytes is called the volume boot record, or excuse me, the master boot record. The master boot record is where what would typically include the master partition table, the MPT, as well as some bootloader information and some directions for the firmware to go and look elsewhere on the disk for the operating system, the kernel and that kind of stuff. All right, so here I would take a screenshot of this. I would highlight this, take a screenshot of it, and say, "There's my master boot record." Okay, you want that's I'm giving away too much of this assignment, but that's what I would do. Now down here, these last what do we got? 64 times 4 is let's see, that's 64 bytes. That's 64 bytes. That's 128 bytes. So these 512 bytes down here, these last 512 bytes minus, well, this 55AA is your signature, your file signature for your master boot record. So you know you're looking at the master boot record. But right here, those last 512 bytes that we're looking at are what's called the master partition table. And typically you would see in the master partition table, you would see the partition scheme of this hard drive. But this is something different. This is not a master partition table, which makes me wonder, why is this? Is this really a master boot record, or is this a volume boot record? So, we're gonna have to do some digging and find out. But right now, I see some error messages that where there would be a master partition table, which would indicate what kind of operating system, what kind of file system we have. We're seeing an error message that a disk read error occurred. NT loader is missing. NT loader is compressed. So this is kind of leading to my hypothesis that maybe this was a virtual disk, right? This was from VMware, Windows XP VM, and that this image was created from a VM instead of from an actual Windows drive, because I would expect to see some partition information down here in this master partition table. Now, do I expect you to know that right now? No, that's something we'll get into in 105. But this is your master boot record. To me, it looks more like a volume boot record than a master boot record. I'd have to do a little bit more research to make sure that I'm right? Because even though I've been doing this for 6 or 7 years, or longer actually, there's times when you scratch your head and go, that doesn't look right. It's something's not jiving. I'm not sure what's going on. I'm gonna have to do some homework. I'm gonna have to go see what other experts are saying and finding in this field. So I would do my homework. I would go out there and look that up. So anyway, here's the root directory. I would definitely document some information from the root directory. Look at all this juicy information that FTK Imager gives us. And you could take FTK Imager at face value and just report this, which for this report, I'm okay with. You're probably not going to have to go out and do too much more verification, right? I just want you to document that you're going through the process and you're thinking about certain things that are here. And you're going to do it with both FTK Imager and with Autopsy, because that's what the assignment called for. Incidentally, I didn't create this assignment, but we'll go with it. That's what was approved by the course champion, so we're good. We've got some unallocated space here. Well, let's finish looking at the root here. In the root, you see some really interesting things. Not only do we get this really great metadata parsed out by FTK Imager, which gives you a lot of information down here in this lower right-hand corner. And I would carefully document critical pieces of this and tell me why you're documenting that. So take some screenshots and then give me some good sources and why experts would document that. Okay, give me some good reasoning behind it. Also, in the root directory, here's what we see. We see these $ attribute files. These are actually file system files for the NTFS file system. You don't really need to know that right now, but it helps. Okay, helps to know that. Boot INI. There's part of the there's the bootloader for the Windows XP boot up, and then there's some other .sys files here. NT detect. NT loader is missing. Oh, look at that. NT loader has been deleted, and isn't that funny? Because in our volume, in the master boot record, or at least what we think is the master boot record, possibly a volume boot record, it tells us right here NT loader is compressed and missing. Yeah, that's a problem, right? How do you load an operating system without NT loader? Something's fishy here. Like I said, what is it? I'm not sure. Not sure. Gonna have to do some homework. Okay, but when you do your homework, and you start looking, you go, wait. Here's all of my operating system files in the root directory where they should be, except NT loader is missing. Why is NT loader missing? It's been deleted. That red X tells me it's been deleted. I would take a screenshot of that. Okay, and then I'm gonna have to do some more digging. Okay, here's some unpartitioned space. Oh, wait, what the? We click on unpartitioned space, which we know is not actually a file on the actual hard drive, but FTK Imager categorizes it for us neatly and nicely. And so we got a file folder here with a bunch of other unallocated space in it. Okay, some interesting stuff. When I say interesting, I mean that completely sarcastically. There's nothing there. But under the unpartitioned space, there's a master boot record. That's really weird. That's really weird, because why would there be a master boot record in unpartitioned space unless it's left over as file slack from something else? And again, it says something weird here: invalid partition table error, error loading operating system, missing operating system. Yeah, well, there's no operating system um, for this master boot record, and there certainly isn't. Oh, wait a minute. There's a master partition table. It only has one partition. Again, I don't expect you to really know this until 105, but I'm just throwing out some insights here. This first 64 bytes of the master partition table tells us that the 80 at the beginning tells us that this is a bootable partition. It also tells us that it's a NTFS file system. How do I know that? Because I've looked at too many of these. That 07 tells me that that's the flag for NTFS. And then it also tells us some starting locations, I believe, starting clusters for the file system. So that's very interesting. There's some interesting stuff here. I don't expect you, again, to go in and find all of those details, but you might want to take a screenshot of the master partition table and indicate that there is a partition there that is somewhere else. There's something weird going on here, right? Because I would have expected to see the master partition table, or the master partition table within the master boot record. I would have expected to see that way up here at the beginning of the partition, the first sector of the partition, but it's not. There's something fishy there. All right, so take lots of screenshots, document, go to outside sources, look up what other experts are saying. Not me. Don't use this YouTube video as a reference. And then do the same thing with autopsy and see if you find similar or different kinds of information. Each forensic utility parses things out and reports things in your GUI interface a little bit differently. And that not one is right and the other is wrong. It's just a different way of looking at information, but we need to be aware of that so that we're not just reporting something and making assumptions without double checking it against a second utility. So it's kind of like when your doctor tells you you have cancer and you're going to die in 3 weeks. You're going to go get a second opinion, right? So if you find the smoking gun using FTK in the crime of the century, you sure as heck better go see if you can find the exact same smoking gun using a second utility to make sure that you're getting the same metadata parsed the same way. Otherwise, there may be some confusion and you may get your case thrown out, or at least get your evidence thrown out. It's happened. Casey Anthony. Okay, so I think that covers the tutorial as best I can in a short, brief, just a brief explanation. I hope that clears it up for you, clear as mud. You guys have a great week. Participate in the discussion questions and turn in your homework. We're getting there. This is week 4. We're almost done, right? We're almost done. We got one more week after this. All right, we'll see you.